Good afternoon everyone. I am Chanda Devnath, one of the PMRF fellows of ISAR Badampur. And the TA of this class named is Study Guide in Organics, Retrosynthesis and Problem Solving Approach. So here I usually discuss about some important organic reactions including name reactions, important reagents and all, and some questions based on that which may help you to plan retrosynthesis of any important molecule. So I have already discussed all these name reactions and many more which I haven't mentioned yet. I have already discussed all those. You can go and check my previous videos. I have also discussed some olefination reactions followed by their reactions, some reactions without reagents like the thermal and photocatalytic reactions. Then we jump to the what is retrosynthesis, and we also solved some retrosynthetic route for some important molecules last week. So today we will carry forward that one. So in the last week I gave this one as an homework to try by you guys, so that you can get an idea how to approach to a question or how to show the movement of the arrows. So let's solve this one. I hope many of you already have solved. So if you add excess HBr, as they have already mentioned that we have to add excess HBr. So similar to this alkene, this center will also be brominated. Similarly, as similar to the double bond. After the, so this is our D. After that, if you add potassium trisulfide hydroxide in excess amount, it will undergo an Now if you perform ozonolysis, these two bond alkene will be ozonalized. Okay. Now as the ozonolysis has been performed in presence of Me2S, so there will be no further oxidation. It will stop at aldehyde step. There will be no such further oxidation. It will stop at aldehyde step. What will be the correct answer? Correct combination of reagent to get this product from this substrate. So what is the difference? There is a carboxylic group here and there is a double bond. How is this possible? So this reaction will go through this reaction will go through Shapiro reaction. Whenever there is a carbonyl transformed to alkene with a new group incorporation, always think about this Shapiro reaction. Whenever there is a carbonyl from instead of carbonyl, there is a double bond here at the alpha position, and there is a instead of carbonyl if new group has been incorporated, always think about Shapiro reaction. This part is two molecule of butyl lithium, first molecule will take a proton from the nitrogen, this heteroatom proton, that is more acidic. The second molecule of butyl lithium will take a proton from this alpha position because of the resonance stability. This proton is because of this resonance stability, this proton is acidic, so it will take, second molecule of butyl lithium will take this proton. This negative charge has been delocalized and TS group has been eliminated, but this negative charge is still on the nitrogen atom, so it will be also delocalized. As we know, the nitrogen-nitrogen triple bond formation is always a stable because it forms the N2 bond, that is N2 molecule, that is a neutral molecule. So there will be minus N2. Now if you just add any electrophile, it can react with this negative center. So here the newly incorporated group is CO2H group. So to incorporate CO2H, the synthetic equivalent of CO2H group is always carbon dioxide. The synthetic equivalent of our CO2H group is always carbon dioxide. Always remember, the synthetic equivalent of carbon dioxide is carboxylic group is carbon dioxide. Carbon dioxide, for synthetic equivalent of carboxylic acid is carbon dioxide. Synthetic equivalent of CHO is DMF. Means to incorporate CHO group we always use DMF. To incorporate CO2H group we always use carbon dioxide. Synthetic equivalent of CH2OH is ketone. Sorry. Is formaldehyde. Okay. To incorporate all these functional group as a synthetic equivalent, we can use all these things. So to incorporate CO2H group, we will just use CO2. How this react? If you show the bonds, oxygen carbon form 4 bonds, so this will attack to the one of the carbon atom and this will open up. It will take a proton from solvent or through workup, it will be protonated and will get okay. Let's go to the next one. What will be the major product formed in the following reaction? What will be the major product formed in the following reaction? Let's go step by step. The first one is zinc. Whenever in a brominated compound, if you are adding zinc, it will be a, this is a alpha bromo. With respect to keto, with ester, there is a alpha bromo. Whenever there is a alpha bromo ester, that will undergo the Reformatsky reaction. So zinc will be incorporated into this carbon Br bond. zinc will be incorporated into the carbon Br bond. After that, now these centers becomes electronegative, nucleophilic. So in the next step, they have added I have some confusion with this question. I will come back to it after some time. So let's go to this one. I have some little doubt with this one. I will check once with the options, then I will come. The major product formed in the following reaction sequence. So if you add acyl chloride, then ethyl acyl chloride, there is a OH group, so this will be acylated. The next step, if you add LDA, minus 78 degree, it will take a proton from here, phenolic proton. And TMSCl has been added, so OTMS will form. The next step, heat has been provided. So in presence of heat, it shows like a Claisen substrate. So 1,3 sigma topic reaction can be possible. So this one will break like this. The next step, they have added H3O plus, so this will be protonated, and also this will be also deprotected, giving us this will be deprotected. the next step, they have added diazomethane. They have added diazomethane. In presence of diazomethane, this acid group will be esterification, undergoes esterification. So the correct option will be option D. Correct option will be option D. So in presence of diazomethane, it will form ester, and correct option will be option D. The major product formed in the following reaction sequence. This reaction I have already talked about. This is ester-Moser reaction. Maybe I have already used this, solved this question also. For a recap, just try. So if you add H2O to NaOH, alpha beta unsaturated double bond get epoxy undergoes epoxidation. So it will be epoxidation. In the next step, if you add TSNH, TS, tosyl hydrogen, in the next step, if you add base, potassium tertiary butoxide, it undergoes a cleavage. These get deprotonated. So in presence of base, now in presence of hydrogen palladium calcium carbonate, it will undergo hydrogenation reaction. And we know that hydrogen palladium charcoal, in this condition it undergoes a cis hydrogenation, always syn hydrogenation. So it will give a syn double bond. So here the double bond is trans. Here the double bond is trans, here the double bond is cis. So the correct option is option B. It will always give a syn double bond. It will always give a syn hydrogenation. So both the hydrogen will be added from the same plane. So the correct option is B. What is the most suitable combination of reagent to get this conversion? So what is the change? Just see, there is a OH group, but the OH group is not there anymore. So you have to eliminate this OH group somehow. So if you just perform, maybe I have discussed about this reaction. I forgot the name actually. So if you add sodium hydride, CH2 and methyl iodide, it undergoes a esterification. Undergoes esterification. Now if you add into this, if you add Bu3SNH and AIBN, it both of them generates Bu3SN dot. This radical react with the sulfur center. This moves here and breaks the carbon oxygen bond, generating a radical. After that, I forgot the name of the reaction, but this is a name reaction. I think I have already talked about this reaction. Just to eliminate OH group without regenerating any other functional group, if you perform elimination or anything, it will generate a double bond. So, or substitution, it will incorporate another molecule, another group into your molecule. So when you want to just eliminate the OH group without incorporating any new part, in that case you can perform this reaction. One radical will be formed here. Now it will, as Bu3SNH is still in the system, this radical will take a hydrogen radical from here. Then we will get this as our product. So the correct option is option A. I hope the mechanism is clear. I am not recalling the name of the reaction, but if I remember it, I will, in the next class, I will try to mention that one. The name of the reaction I forgot, but this is the mechanism. Whenever we want to eliminate a OH group without incorporating any new group, we usually use this one. We have to plan the retrosynthesis of this molecule from this compound. So you have to see what is the change. So this part, till this part is same. There is 4 carbon apart, there is a bromine. 4 carbon apart, there is a, so only new part is this one. Okay, so if you perform the retrosynthesis of this molecule, and break from this place, so what will be the synthetic equivalent of this one? aldehyde can be the synthetic equivalent. The methyl ethyl ketone can be the synthetic equivalent of this one, and for this one the synthetic equivalent will be a grignard. So the combination of reagent is, before performing a Grignard reaction, if there is a keto center, the magnesium can coordinate with that one. So we have to protect the keto center. So first we will use a protecting reagent, that is ethylene glycol, just to protect our ketone. The next step we will use magnesium ether, that will give us our Grignard. The next step we will add this methyl ethyl ketone. So this negative charge will attack to methyl ethyl ketone, this will open up. In the last step, if we add H+, then this then if it attack here, it will open up, it will give us a O-. So this O- will be protonated by this one, as well as we have protected this keto group, that will also be deprotected to give us ketone back. Forward synthesis, try by yourself, it will give you a practice. I have already given the reagents and the backward synthesis. I hope forward synthesis is easy for you. What will be the synthetic route? Starting from cyclopentene. So you have to start from cyclopentene. What is cyclopentene? Cyclopentane is this one. This is called cyclopentane, and cyclopentene means there is a double bond. So this is called cyclopentene. Okay. So you have to start to go such a way that you can use this one as a starting material. So let's try to draw the retrosynthesis first. If we just break from here, in the last class I have already told, retrosynthesis, there is no shortcut or any tricks for retrosynthesis. It is all totally based on practice. How much you will practice the questions, it will give you an idea where to cut the bonds, or from where we can plan formation of new compound. This can be generated from epoxide. Whereas if we functional group interconversion, if we change the OH group with a, this can be a OH. Next is functional group interconversion, FGI. Why do we change the OH group to bromine? Next, if we just eliminate this bromine, now this is cyclopentadiene. we have to eliminate one of the double bond. We just add a bromine here. So what we have gone to cyclopentene. So if you see the forward synthesis, I am drawing in a shortcut way. Rest you guys can try by yourself. From cyclopentene, in the first step, if you add Br2, then it will undergo the bromination reaction, dibromination reaction, and dibromination is always the anti-bromination. Always the anti-bromination. In the next step, if we add a strong base in excess, like potassium tertiary butoxide, strong base, both the bromine will be eliminated. Now for the elimination we need a anti-periplanar arrangement of the two eliminating group. That means the H and bromine should be anti-periplanar to each other. Now this proton is in syn and this proton is the below the plane. So with respect to this bromine, this hydrogen is not anti-periplanar. Similarly for this bromine, this hydrogen is not anti-periplanar. So but there is a proton here also which is in anti-periplanar with this one, and there is a proton here which is anti-periplanar with the another bromine. So both will be eliminated. So if it goes like this way, it gives us cyclopentadiene. After that, I am just drawing the reagents. If in the first step, if you add NBS in presence of peroxide undergoes a allylic bromination. NBS undergoes allylic bromination. So there is a, this is the allylic proton is there. So it will undergoes bromination. So NBS will give us allylic bromination. In the next step, if we just use KOH, the bromine will be substituted with OH. Then we will get this one. In the next step, if we just react this one with our epoxide, we will get our desired compound. Okay. Forward synthesis, just try by yourself. I hope it will, whatever doubt is there, it will be clear. Which of the following are the correct synthetic equivalent for the target molecule? So among these four, which are, like there can be more than one also. Which are the synthetic? So you have to plan the retrosynthesis of this one first to get idea about the synthetic equivalent. So if we just break the bond from here, this will be a negative, this will be a positive. synthetic equivalent of this part. So this can be a OH and this can be a ketone. With a methyl. Now see, there is a 3 carbon apart, methyl ketone. So this, if you just cut from these two parts, these two are equivalent with each other, same methyl keto 3 carbon methyl keto methyl. So these two part are same. So if we cut from both the side, there will be a negative charge here. Two molecule of this one, and another is this OH with 2 positive charge, because 2 parts have been cutted, so that's why 2 positive charge. So what will be these are called synthons. Okay, whatever the charged species, the unstable species are called synthon. We have discussed it last week already. So if you have 2 positive charge, you have to compensate that one. Whenever there is this type of synthon is generated with the 2 positive charge and OH, the synthetic equivalent will be kind of like this. These things you have to remember, okay? Whenever, so that for simplicity, whenever you have a synthetic equivalent of this kind of OH with 1 positive charge, the synthetic equivalent will be a aldehyde, like or the formaldehyde, CH2OH. It will be a formal, synthetic equivalent will be a formaldehyde. But so if you just consider this part, so the OH with 1 positive charge, the synthetic equivalent is formaldehyde. So this is our formaldehyde, but there is another positive charge. So to compensate, we have to just add a leaving group here. So this is the synthetic equivalent of this one. And for this one, we can use a Grignard. So the correct option is A. Correct option is A, because see what is the difference. There is the number of carbon here is 2, but we need 3 carbons. This is 3 carbon apart, okay? So we need 3 carbon. So don't always check the number of carbons. So C is not the correct answer. Only the correct answer is only C, A. Propose the possible mechanism for this acetal formation. What is the proposed mechanism? So for that one, just plan the if you just try to cut the bonds. So this has been newly incorporated. So we can cut this bond. You also see this is a straight chain. The ring has been formed. So we can cut this bond also. So first, let's go one by one. So if you just add a leaving group here to compensate the positive charge, It is a OH. Now just bake this bond. So the correct mechanism is this OH will attack here, it will open, give us a OH. After that, that will be protonated, and this OH will attack there and eliminate this one. Next step, this OH will be protonated again and it will positively charged. Then this will attack here and substitute this. Okay. Draw the specific reagent for these three transformations. So see the change. There is a OH group here instead and 3 carbon apart. 3 carbon. There is this center has been converted to a keto, and this part has been attached. How is this? How we can perform this one? This transformation. How you can perform this transformation? Just perform oxidation. This will be oxidized. In the next step, if you add ethyl magnesium bromide, it will be incorporated and give us this so not ethyl, it will be propyl magnesium bromide, because this is 3 carbon, 1 2 3 carbon, so we have to use propyl magnesium bromide in propyl magnesium bromide. Next, if you perform again oxidation, this OH will be oxidized to give us ketone. Clear? What will be the reagents of this one? In the first step, if you perform Suzuki reaction with phenyl boronic acid, Suzuki reaction we have already talked about while discussing about coupling reactions. So if you perform Suzuki reaction in presence of palladium catalyst, it will give us a pH here. In the next step, if you perform allylic bromination, that is NBS, then there is only allylic position, this is this one, so that will be brominated. Okay, it's just simple. What will be this type of question we have already solved. Whenever there is a alpha beta unsaturated double bond formation from a ketone, always go through a selenium oxide mechanism where you will add base and pH selenium Br. Then at the alpha position selenium will be incorporated. In the next step, if you add MCPBA, R oxide, selenium will be oxidized. Third, if you add heat, it will undergo a scene elimination. It will undergo the scene elimination. It will undergo the scene elimination from this with this scene hydrogen. Undergo scene elimination to give us this double bond. So this much. So you have this question remaining. So if you this center becomes electronegative. Now if you add phenyl selenium Br, there will be an incorporation of selenium. Now this is below this negative charge is there, so as this is below the plane, so upcoming selenium will be from the above the plane. Because this is below the plane, so upcoming selenium will be from the above the plane. Okay, in the next step, if we add MCPPA, selenium will be oxidized. While bromination, while zinc will be incorporated, this zinc will also incorporated into the, because there is no selectivity, so zinc will be incorporated on this bromine also. At this place also. Okay, this will be also brominated. Now in the when MCPP has been added, MCPP is bit acidic. We know that MCPP is bit acidic because it is a peroxide. There is a acidic proton is there, so MCPP is bit acidic. So in presence of acid, this zinc Br will be protonated. So this zinc Br will be protonated, while this selenium get oxidized. In the next step, now it will undergo elimination, but a syn elimination. So you have to see there is a hydrogen here, it is syn to the selenium, because this one is below the plane. That's why stereochemistry is very concerning. If you incorporate the selenium below the plane, then there will be no H available, syn H available adjacent to selenium, then there will be no chance of elimination. So while there is a question, whenever there is a question denoting the stereochemistry of the bond, always keep it in mind that while drawing the product, the stereochemistry is concerned. So as we are incorporating this above the plane, so there is a proton is available which is at the same plane, so it will take up this proton and undergo syn elimination. There will be a double bond here with the alkene chain and a methyl. So the correct option is, so as we have seen from the mechanism, so this triple bond will form a mercury cyclic intermediate with this mercuric acetate. Now instead of water, they have given benzyl amine. Instead of water, they have given benzyl amine. So benzyl amine can attack to this cyclic transition state and it will open up. Then the question is, which center the benzyl amine will attack, from this center or this center? So as we have learned that this always follows the Markovnikov rule. According to Markovnikov rule, the center containing more hydrogen will always get the hydrogen. So it will follow the Markovnikov rule. Therefore, this benzyl amine will attack here, so that it will open up and this center will be vacant for hydrogenation, and hydrogen will go to that center which is already rich in hydrogen. So it will attack here, this benzyl amine. After that, this amine will attack to this carbonyl center. Then there will be elimination of water. Generating a double bond here. And to gain aromaticity, this proton comes here and this goes here. So the correct option is option D. Okay. Understood? Let's go to the next question. This is also based on the same concept. I just give 5 seconds. Just solve by yourself. I just give 5 seconds. the major product of the following reaction is. So let's go step by step. As you know that mercury will be added here and H will be added here. Sorry, OH, as OH is given, so OH will be added here. I am just jumping the step, okay? Till I think you have understood how I have gone through. As it follows the Markovnikov rule, so obviously the OH will go where the number of hydrogen is less. So OH will attack here and mercury will attack here. After that, if you NaBH4 will add it, this bond cleave and we will get this as our product. So the correct option is option C. Oh sorry, not option C. Then now as NaBH4 will not only reduce this carbon mercury bond, it will also reduce our ester group. So in presence of ester, this will attack here and this open up. So the correct option is option D. Correct option is option D. Okay, understood. Only this center will not attack, right? Because all this hydrate source and also our OH minus is provided. So that will open up this ester and forms the alcohol in the same medium, reaction medium. So correct option is option D. Option B. Okay. So today we have already discussed this one. We kept for today. Last week we gave this as a, so you guys can try by yourself, solve this one. Then we solve some other questions and some retrosynthesis of some compounds using whatever reactions we have learned till now. So thank you everyone. This much for today.
Ma'am,
Yes.
hello.
Hello.
Ma'am, I have some question. The actually I'm unable to attend all the classes of yours. So how I can get this papers which you solved in the classes?
I have already
Can you
uploaded the
help?
slides. There is a drive has been provided by the NPTEL. So in that drive I
Oh,
have uploaded the slides. From there you can get all the slides. And the video links are also already also has been shared.
the recorded video. Should I get the recorded video in of the
Yes,
classes?
yeah, I have shared the links. So from there also you can get the recorded video total.
Oh, and one more question, ma'am. How I can improve my course progress? Actually, I now I
Sorry,
that
actually their voice is cutting. Can you repeat again?
ma'am, how can I improve my progress of the course? It's shown me very low, 90%. I don't know how to improve this. Actually, I submitted regularly the only assignment,
For
but
assignments, actually assignments uh, are based on like previous year netgate questions they are coming from. So for that one,
actually, not always related to the lecture video. I found it, but I don't know how I can improve course progress.
you can just
I
whenever you are
where
studying the course, if you are going through some like in course they are just going through like how to plan a retrosynthesis of that one. Along with that, try to read some more about some important organic reactions and all, because in assignments they usually include the reactions, like the name reactions. They mention a name reaction. If you don't know what is the reaction is, you can't go through. So whatever previous assignments you have already done it, just go through the assignments, the name reactions whichever has been mentioned, just type it in Google or something somewhere, and learn about the name reactions and how to solve the questions of based on this reaction. Then solve the previous whatever assignments has been already done, just try to solve those one again. Just learn the name reactions and all, then go through the assignments again and solve it by yourself. Then try to attempt the new one. You will find it bit easier, because because whenever you are trying to solve any assignments, you have no background knowledge, then it becomes very difficult. So whatever is the solved one, just try to solve that one again and again. When you can confident that okay, this if this type of question comes, I can solve it, then maybe get improved. Try to solve the questions which answer you already know. Okay, so that you can, whenever you are solving that one, you will get the answer, then you can match. Okay, I'm going in that, your confidence will be boost up. Okay, or otherwise you can go through some other books also for the name reactions, whatever has been mentioned, you can try to read from books. Because if you just go through the assignments and videos, there sometimes, if you have any understanding issue or some, if you can go through some books also, books may help you. Okay, so I have uploaded all, I think till my 9 weeks videos have been already uploaded. I will upload these 2 videos also. Okay. Thank you everyone.